Right, in today's class we are going to discuss about design concepts. Right, so the fundamental software design concept provide the necessary framework for how we are going to get a program for particular function, and whether it is suitable one or not exactly. Okay, here we are going to recognize the difference between the program, and it is a right program or not to that particular function. It is a right program or not to a particular function of that project. Right, it is suitable to that project or not. If you chosen one program, okay, that program is if you want to insert one program into your project, so after inserting that program into your project, so that program is 100% suitable at that function or to finish that particular task or not. If there is a difference, how much difference you will get. If it is 1%, 2% means it's okay, we can edit that program, then we will use that program. If not, it is giving more than, I mean, more percentage difference percentage, okay, then it may be not suitable to that particular task. What we would do at that situation? Okay, this design concept purely concentrated on, okay, purely concentrated on to find out the difference between the program and the result outcome of that program. If there is no difference or it's a less difference means we may use directly that program into our project. If not, then better to avoid that one, or otherwise use some other what program into your project. Clear? So it provides a design concept, provides a necessary framework for getting the programs, okay, getting a suitable programs to our project. It is the main motive of design concepts here. Right. So design concepts, this design concept or everything here we are following one basic concept. It's a modular solutions for any programs, or here we are going to decompose a main problem into multiple number of sub problems. Already we have discussed in yesterday's class. Every problem, if one design, okay, call a good design means it would be, okay, divide a complex program into a number of sub programs, then find out the solution for each and every sub program here. So when our design is called a good design, so we will divide the biggest problem, okay, into a number of sub problems, then provide the solution for each and every sub problem. Okay, by doing like this, then we reach some good design, isn't it? So while doing this design, to reach this design modularity or design concept properly, here we are having, okay, some concepts whichever we need to remember for our for design concept. What are those? The first one is abstraction. What is the first one here? Here it is a abstraction. Abstraction may have it's a data abstraction or processor abstraction or a control abstraction. Here again we are having three kinds of abstraction. Okay, while providing a modular solution for any problem. And also the second one is the architecture, third one is patterns and separation of concerns, modularity and information hiding, functional independence, refinement, aspects, okay, refactoring, object oriented design concepts, design classes. Design classes. If we'll follow all these, okay, then we should tell the program whichever we have designed, okay, that is suited to our project. That is suited to our project. Okay, these are the some framework activities, okay, to reach the design concept here. Let us discuss one by one individually. Let us see one by one individually. What is the first one? First one is a abstraction. So, what is data abstraction here? Data abstraction in the sense, here we are going to follow many levels of abstraction. Okay, there are from highest level of abstraction to a lowest level of abstraction. Okay, based on the problem, we are going to show only few details, a few details about some problem. If we are studying in detail about that particular problem, it would give remaining the details about that particular problem. Okay, what is abstraction here? It will show essential details by hiding the unessential details. That is basic definition about a abstraction. It will show only essential details by hiding implementation details, isn't it? Here in this abstraction concept, we are going to, okay, learn about data abstraction and procedural abstraction. Data abstraction and procedural abstraction. What is this data abstraction called? It is a collection of attributes related to one data objects. Okay, in data abstraction is a collection of data attributes that describes a data object here. For example, one data object here we have taken one data object, that is door. That is door here. Door is one data object. What are the attributes related to that particular data object? Okay, it has some set of attributes. One is door, manufacture size, manufacturing, and model number, type, swing direction, okay, inserts and lights, and weight, opening mechanism. Okay, many attributes we may have related to a door. So mechanism, how to opening mechanism of that door, and height and weight of that particular door, and some which kind of wood we have taken for manufacturing that door, and model number. So like that, there are many attributes are included into this particular door, isn't it? What is door here? Door is one of the data object here. So while showing it would be hiding these implementation things. Whenever we are going to discuss about, only we are going to discuss about door. And what are the here, the door has many attributes. That attributes are the implementation details of this particular door. When the situation rises, just we are going to use only door. We are not thinking about all these things. Once the door is fitted into our house or for particular room, okay, would we concentrate about this implementation details? No, only, okay, we are using this particular door, that's it. This is about data abstraction. Here we are going to hiding the data of a particular door. Data in the sense attributes of a particular data objects. Clear? If we'll see the second next slide, that next slide has about procedural. It's a procedural abstraction. Till now we have seen the data abstraction of procedure. How this door will work. How this door will be worked. Okay, the procedure. How we are going to open this door and how are we going to close this door. There is some kind of procedure is involved into this particular door object, isn't it? There is a open mechanism, there is a closed mechanism. So those are also a implementation details. Exactly, here we are having those. Okay, here we are having some sequence of instructions that have a specific and limited functions. Okay, a specific and limited functions, but those function specific details also mean suppressed. Okay, knowledge, implementation knowledge, which means details of details of enter algorithm. Okay, that lock is made of puff with something, some mechanism, opening mechanism is there. Okay, how that, which kind of algorithm is built with that particular, okay, locking mechanism. We don't show to that particular customer. Just how to open the door. We have given such kind of instructions only. Okay, by entering some number, you will get opened this door. That's it. But if that customer is entered some numbers to open that door, how it will be matched to the inside in what it's there inside, and how it is matched with the inside code. If it is, I mean, if it is true only, it will be giving the permission to a customer. Otherwise it would be, okay, locked. It won't give the accessing permission. Okay, something that technology, the procedure is used into that particular, okay, particular locking mechanism. It's not revealed for anyone. This is called a second kind of abstraction here. One is data abstraction, second one is a procedural abstraction. How the internal algorithm will be worked to open that particular door. Clear? There is the abstraction. Coming to the next slide, architecture. So what is the architecture, software architecture here? Here we are going to discuss about the architecture, the overall structure of the software. The what is an architecture here? It is a uh, it is the overall structure of the software and the ways in which that structure provides conceptual integrity for a system. Overall structure means it has many modules, many functions within it. It should integrate all the subparts. It would integrate all the subparts, submodules, modules of a particular project and get ready to work, isn't it? So That is a software architecture here. And also, this architecture is the structure or organization of the program modules. If we'll take some other definition for software architecture, in the sense, it is a structure or organization of a program modules to fulfill the requirements of a project, isn't it? And here we are having some three kinds of properties for software architecture. First one is a structural properties. Structural properties, extra functional properties, and families of related systems here. What are the structural properties have? This aspect of this, the architectural design representation defines the components of a system. Components of a system means modules, objects, filters, whatever the things whichever we are using related to that particular project, okay, are called the structural properties of a system. For example, objects. Objects. Objects are packed to encapsulate the both data and processing. So here the objects all are combined or packed into by using some interfaces for storing the data and the process of that particular, okay, structures here, I mean particular function here. So what is the structural properties? The structural properties, okay, we'll talk about the modules or objects of a particular project. And extra functional properties means how the design architectures achieves the requirements for performance, capacity, reliability, security, adaptability, and other system characteristics. So, while working with our software project, we may include some, not only the here the functional requirements are the user requirements are divided into two types. One is functional requirements, second one is a non-functional requirements. Functional requirements will come under a structural properties, non-functional requirements come under a extra functional properties. Okay, the functional properties relate means, so each and every function, okay, each and every big function and small function, how it is working, how it is taking the input from a user, and how what it is produced after processing. Okay, such kinds of things would come under a structural properties here. Okay, for every function, for every small function, okay, for every big function, some kind of inputs we need to we should enter, then only it will be acted and it will give some outcome. For example, if we'll take some ATM, okay, ATM is one module for a bank project. Okay, ATM is a module under a bank project. So if we'll take ATM module has many actions, which means many activities. What are those? One activity is a withdrawing amount. Okay, some other activity is transferring amount, and some other third activity is depositing amount into a ATM machine, or fourth activity is pin changing. So like the different activities, different functions we have within that ATM module. So how the user is interacted, or how the user is used such kind of used such kind of services. If we want to draw money, so how he is going to choose that option? Okay, first of all, he should insert his ATM card into that ATM machine. Okay, then Then he needs to select some account type. After that, first he needs to select some withdrawal option. After that, he should select some account type. Then he should enter some amount, 5,000, 10,000, 20,000, like that. After entering the amount, okay, it would ask some PIN number. After entering the PIN number only, it will process everything. The ATM machine will process everything, and it will give the money to us, to the customer, isn't it? So, which kind of information is provided by a user, and how it is processed for that particular information, and how after that the user is getting some amount from that ATM machine. So the customer given some input related to the amount and some PIN number related to that ATM card, etc. That is input. Input is provided from a customer for withdrawing amount. Based on that input, okay, it will process the things and it will count the money. Later it would give some output to the customer. What kind of output it is? Okay, returning cash amount to the customer. That is one kind of functional property. And if we'll take second function, third function, for each and every function may take some input and it will produce some output. So such kind of things all will come, such kind of things will come under a what functional requirements, or otherwise structural properties. Apart from that apart from that our system has some other non-functional properties. What are those? The ATM machine is providing security. Okay, it is working with a good performance. Within a 1 minute or 2 minutes of time we are withdrawing some amount. So what are the non-functional properties or extra functional properties related to a ATM machine means, that is about performance, capacity, reliability, security, adaptability, etc. Right? And along with this, here we are having some families of related system. The architectural design should draw upon repeatable patterns that are commonly encountered in the design of families of similar system. Okay, if we have some designs already existing or universal designs, some design patterns are available in market. We may use, okay, we may take those designs into our project. So that is about, okay, that is about families of. So, from universal families of patterns, some design patterns already, here we are having basically 23 design patterns are available. 23 design patterns are there. Those are the universal design patterns. If your project, if your what module or submodule is, okay, similar to any kind of design pattern, you may use that design pattern into your program project. Okay, like that you may use the patterns to build your program, so to build your architecture. Clear? So this is for reusability, or reusage of a design codes. Clear? This is about a software architecture. Next, patterns. Okay, till now we have discussed patterns. Now, pattern in the sense, already we have discussed that it is a it's a design pattern template. Okay, it's a one kind of template. The template may have pattern name and the intent of that pattern name in the sense, if we have one class means class name, like that pattern name. What the pattern name would have? that is related to a problem, which kind of problem, for which kind of problem we are going to provide the solution. So that is a pattern name here. So intent, so which purpose? Okay, describe the pattern, what it does. Description of a pattern. Okay, providing a solution to this kind of problem, like that you need to describe in intent. Also known as, okay, is there any similar patterns are there or not? Synonym for patterns are similar patterns. So motivation in the sense, provide an example for the problem, which kind of problem you are chosen. Is there any examples related to that problem or not? Real time uh, problem problems and solutions are there or not? And applicability, whether it is applicable to your, okay, specific design or not. And what is the structure? Describe the classes that require to implement the pattern. How you are going to choose your classes. In structure you are going to describe the classes. And participants, so who are the participants? It describes the responsibilities of the classes. Responsibilities. So I mean, class name means is somewhere when if something, one class is responsible for all the things. So like that, is there any things are there or not? And collaborations means, so so how the things are sharing in between the classes to fulfill our project. Okay, describe how participants collaborate to carry out their responsibilities. Sharing the things. Clear. So, is there any consequences? Any problems would get if you will provide the solution for this problem? So, any other consequences problems may get after getting the solution. Okay, those are the con. And any related patterns, some cross-referential related design patterns are there or not? Right? So this is about a patterns here. Next, so it's a separation of concern. Here the concern in the sense, what is a concern here? Concern is a feature or behavior that is specified as a part of requirement. Okay, requirements model for the software. So separation of concern. So sometimes there are some features or behavior we needed for many functions, whichever whichever we are going to use in our project. If there is a complex problems, those complex problems are subdivided divided into a sub problems, and each and every sub problem may be worked independently or not. If we divide some one problem into two sub problems, those two sub problems are worked and executed independently, or those will be dependent from one with another or not. Okay, here while going for dividing such kind of problems, okay, we must what divide based on their independenceness of that particular sub problem. What is if one is dependent on another one, means what is the need of what dividing? It's a useless thing, isn't it? If we divide something, the two problems will be worked independently, then our time would be saved parallelly. They would be worked and will get a result fastly. Okay, if we have some task, if we have some task, which means if there are two students with us, suppose I asked one student please read second unit, and another student please study the third unit of syllabus. If they would read independently, and okay, they would prepare accordingly for the examination, means without interacting with that people, I mean without interacting their self, they can prepare their individually, and they'll give the, I mean they'll submit the uh, work work to me, whatever I have given to them, it's okay. But if I hand over two different works to these two people, then they will be worked togetherly to finish off those works, means what is the need of dividing the tasks, isn't it? If we divide the tasks, means it would save our time, it would save our time, isn't it? So if those, here also the same thing, if we divide one module into a number of sub modules, means those would be work independently, not dependent with others, and they would show their own behaviors. Clear? So here we are going to concern, in the sense it's a problem or some what it's a one module, or it's a problem. So we would what separate these problem into a number of sub problems, sub pieces, then it would give a best result to save our time, and also it would give the efficient result. That is the separation of concerns in the sense, just it's a problem, it's not a new word here, this is a just one module or a program. It's a separation of a program into a sub programs. When we would what apply that dividing concept, means automatically, okay, it would give the best results. Coming to the next slide. Modularity. So this modularity also the same thing. So what is the need of modularity, why are we going for this modularity? Okay, modularity is the single attribute of software that allows, okay, modularity, it's a single attribute of a software that allows a program to be intellectually manageable, which means if we have a monolithic software that cannot be easily grasped by a software engineer, which means monolithic software in the sense it's a big kind of problem, which means one program may have 1 lakh lines, 1 lakh lines of code. Okay, is it possible to understand where we could get some kind of problems if some problems are raised, and is it possible to check which line we would get this kind of error like that? It's impossible. So that 1 lakh lines of code would be divided into a small number of parts, which means we would divide the total code into a number of modules based on a individual functions. That is called modularity here. Then it would be easy for a software developer, software engineer, isn't it? If we divide the complex thing into a small programs, then we would understand easily, we would rectify the errors easily. If any kind of problem would occur, means based on that particular thing, we would check that better, I mean check that lines of code only, not overall problem, overall project, isn't it? In almost all instances, you would break the design into many modules. So for better understanding purpose, and also to reduce the cost, also to build the software, to build the software. So why are you reading each and every subject into a units, chapters, and individual topics like that? For better understanding purpose, for better understanding purpose, isn't it? So every subject may have some number of, okay, 10 number of units. Each unit may have two chapters or three chapters or four chapters, and each and every chapter may have, okay, concepts. So like that we are learning some subjects because of, okay, for some understand easy understanding purpose, isn't it? So by doing like that, it may save our time also, it may save our time also. It would give some interest, it would give some interest while studying concept wise. If you'll study one concept now means, okay, you would understand one concept. Okay, we are we are very we are very much satisfied by learning one concept today, okay, instead of learning overall subject, isn't it? Here also this same this modularity concept is used in the same manner. And this is about the modularity trade-off, which means how while dividing one program into subprograms, how so how many number of subprograms, how you are going to estimate, okay, one big problem into if one big, if you want to divide one big problem into a multiple number of small problems, okay, so how many number of small problems I should take here, I should take here, okay. So that is a modularity trade-off here. So here number of modules based on the, okay, software cost of a software. Here the y-axis having the cost of a software and x-axis having the number of modules here. Okay, so always there is a reason here, there is one middle one reason you would find, no, that is it would show the how many number of modules you are going to split your problem. That is the best solution, okay, based on the cost you are going to divide a problem into a number of sub problems. Clear? And the next one is information hiding. Information hiding in the sense, um, already you know, same concept we have seen in this abstraction, okay, it will hide something details, it will hide some implementation details like that. So what we are going to hide, which kind of information we are going to hide related to a, okay, specific design, what we are going to hide here, okay, what are the algorithms we would use into that particular design, and what are the data structures we would implement in that, and also details of external interfaces, resources, resources and resource policies, okay, these are all the hiding things, hiding things under a particular task, okay. So if we'll take the same example of ATM machine, actually we don't know how it is counting the amount, how it is counting the amount, and also how it is updating the, okay, what our bank account after withdrawing the amount, isn't it? So which kind of algorithms those people are using for the transaction, we don't know. Those are all called the hiding things, at the customer point of view, isn't it? Okay, that is called the user is working with some withdrawing some amount or something. Okay, some work he is doing some work. Okay, everybody. But okay, this is the client. This is the client part. Okay, this client part means just he is going and doing some. He is going and using some services which is provided by a ATM machine. But while providing the services to that particular client, so how it is providing the service to me, what's going on within in what is the internal work of that particular ATM machine, nobody knows exactly, except only developers, isn't it? That is called information hiding here. And coming to the next one, so what is the need of information hiding? So there are different reasons are there for information hiding. Okay, so better we'll skip out this concept. Already got the information hiding topic. I mean concept clearly. Better go through this slide. And coming to the next slide, that is functional independencies. Here the functional independence is achieved by developing modules, okay, with a single-minded function and an aversion to excessive interaction with other modules, which means whatever the functions we have designed and developed, okay, those functions, if one module those functions should be, okay, interacted less with the other functions, less with other functions, with the same module or with a different modules. Like that we would develop functions of a module or functions of a project here, right? Here there are two things we should, while designing this functional independences, here we need to consider two things. One is cohesion, second one is a coupling. Okay, cohesion in the sense how one function is, okay, has the relation with another function. If one module has, okay, more than one function here, so how those functions are interrelated to one with another. For example, there is a balance inquiry option with our ATM machine, isn't it? So if we don't know how much amount we have into in our bank account to withdraw, then first of all we would check, we would go for a function of balance inquiry. After completion of balance inquiry function, then the next step we are going for a withdraw function, isn't it? Here there are two functions within a ATM machine. One is what, balance inquiry, second one is withdraw. If you want to withdraw amount, okay, before going to withdraw some amount from your account, then first of all you need to check how much balance you have in your account. Based on that only you would withdraw the amount from that bank, isn't it? So here how much these two functions are related to one with another, related to one with another, how strong those are related to one with another, such kind of things will come under cohesion. Next, coupling. So coupling in the sense here, how one module is dependent on another module. In cohesion we have discussed uh, within a module one function is dependent on another function, how much it is dependent on or how much it is related to a another function. Okay, okay, one function to another function discussion in cohesion within a single module. But coming to the coupling, it is in between the modules, how much one module is dependent on another module, how strong those two modules are coupled, weakly coupled or strongly coupled, like that. Okay, so based on that only the functions would work, which isn't it? If we don't know the balance of our okay account, then how would we draw, isn't it? So some functions would be what related strongly. This is about functional dependencies. And next one is refinement. Refinement in the sense it's a just it's a simple statement. It's a top down design strategy. Okay, it is actually a process of elaboration, a process of elaboration in a hierarchy manner. Suppose if we'll take the same example, the previous old example, what it is, if you want to open the door, if you want to open the door, that is a main task. So what it is includes, first step, walk to the door. Second, reach for the knob. What is the knob we have? So okay, turn that knob for opening the door, and walk through that door, close the door. These are the steps involved into the opening the door. So if the knob is, if the knob is little bit what struck, so what we have to do, repeat. Okay, I mean, suppose opening door, repeat the until the door opens, turning the knob clockwise until the okay door opens. If that knob is little struck means, or otherwise, how would we will work with that knob means, just rotate the clockwise to open the door. If it is correctly matched, then you will pull or push your door, pull or push the door based on that opening what movement side. Okay, then leave the door. If once it is opened, okay, walk through the door, then leave the door, automatically it would be closed. This is the stepwise refinement. Stepwise refinement, which means it is a process of elaboration stepwise. Okay, first how to open a door. So after within these steps, again these steps. This is called a refinement concept. Next, aspect. It's just a small thing. Aspect in the sense, an aspect is a representation of a cross-cutting concerns. Okay, cross-cutting concerns means if suppose we have what we would include two functions into our project. Okay, if you want to include two functions into our project. Okay, if one function already we have implemented, second one is almost 99% is dependent on first one, then what is the use of a second one? Directly we would remove the second from function from our project, second function from our project. Okay, suppose in our house, in our homes, if there are two maids are there. So if a first maid is doing everything, all the things, only second maid is doing only one work or small two works, that's it. So instead of bearing, I mean, instead of maintaining these two maids, okay, allot the second person work also to the first maid, then remove the second maid, isn't it? So like that, such kind of things should be applied into your project. If there is any such kind of necessary, then better avoid, okay, less useful things, functions from our project. That is the aspect here. Next, next one వచ్చేసి next is refactoring. Refactoring in the sense, it is about reorganizing the things. Refactoring in the sense, it is about reorganizing the techniques or things that simplifies the design or code of a function, right? Okay, got it. Refactoring in the sense, reorganizing the techniques for simplifying the code or design here. For this here we are having some, for which purpose, there are many reasons are there for reorganization things. Okay, to remove the duplicates. Okay, duplicates from our okay design or something, whatever the excess things we are having in our project. For removing everything, okay, you should go for a refactoring. Clear? Next, here object oriented design concepts. You would include these concepts into our what project. Already you know, while already you are learning in your OOPS concepts about inheritance, message, polymorphism, and some classes. Okay, entity classes, boundary classes, and the control classes. Everything you are learning in your OOPS concepts. Once, okay, what are the entity classes, what are the boundary classes, what are the control classes. Entity classes means it would represent the overall purpose, entity or object of that particular purpose. And boundary classes meant it would represent the where we are going to stop that, where we are going to stop that particular thing. Okay. And controller classes means by designing some classes into our project, then it would control the, okay, process and everything. Okay, this is about the classes. And inheritance concept means it is responsible for taking the features from superclass. It would, okay, derive the things from a superclass. A subclass derive the, okay, features from a superclass. Okay, messages means it would simulate the, which means take the behavior of the particular object. Polymorphism means one thing would be act as a one object or one attribute may be used for many other programs based on, I mean, one thing may act uh, differently based on the situation or based on the program. One value may be, one variable may be used for different programs, isn't it? That is the polymorphism concept here. And the last slide is that the design classes, whatever till now, whatever we have discussed this one. Okay, this is about today's class. This today's class is completely about design classes.